Yeah, short overview of LUNARC as well, so that you don't miss that we have this resource at Lund University. So LUNARC is the Center for Scientific and Technical Computing. I hope you already have some account on LUNARC. So let's see if I can. So we provide high-performance computing resources to researchers at LU. We provide training and education on these resources. This course is part of that with collaboration with Compute. We provide an environment for scientific computing. So we have an interactive environment where you can log in with a desktop and you can run software with accelerated graphics. You can submit things to the queue. We have approximately 300 compute nodes, and I think this some 700 is a bit too low. I think we have over 1,200 scientific packages available for you to use. And if you have something that you need, we can provide more as well. And if you need some more information here, you can go to the LUNARC web pages as well. This is a view of our desktop here. So you log in here and you can run MATLAB, you can run a graphical file browser. You can also run ParaView, for example, which we go through this course, with hardware accelerated graphics. So we have at least 30 GPUs that are available for graphics as well. So just shortly, I'll go through how to set up a Python environment that you can use. If you log into LUNARC and use that as your main environment, you can just do ML Anaconda 3. So that there is a module that provides you with all the Python in this course. If you want to run it on your own computer at home, my recommended package is using Anaconda Python, which is distribution for scientific computing. So if you go to the Python website, you get just the basic Python interpreter with the packages that are part of the Python runtime. And that is not, you can do quite a lot, but not numerical computing. So Anaconda contains all the packages you need for running numerical computing and some basic visualizations as well. And they also optimize for your computer. So if you're running array computing, it will optimize for that as well. So it will be almost as fast as MATLAB in certain aspects. Installing, you can download from anaconda.com. And when you run it on Windows, it creates shortcuts for starting Anaconda prompt on Windows. So if you want to run Python from the command prompt, you search for Anaconda prompt and you can start and you get the terminal. I will show you this shortly as well. macOS, there is a built-in terminal, and Anaconda modifies that environment that you can run Anaconda within that terminal. And same thing with Linux, it also updates environment so that the default Python becomes the Anaconda provided Python environment. And something also I want to mention here, there are many ways of running Python. I think there's even more than 3 here, but I will just go through the main ones that is kind of related to this course. You have, the first one is running Python through a terminal. On Windows, you open a terminal, you can type Python, and then it -v will show you the version here. That's the Python command that can execute Python scripts and source codes. So that's one way of running it. You can run it through a development environment. So in this case, we have Spyder. For this course, I recommend also using Visual Studio Code, which has an excellent package for Python support. So Spyder, I kind of moved away from that. So we also have Visual Studio Code here, in which if you install the Python packages according to my documentation, you can debug Python code and switch between environments as well directly in this environment. And you can run it through a notebook, which is a web-based system where you combine text with executed code and diagrams. So basically you create a document which has executable parts and which generates diagrams like a report, and it's web-based. I will use the Google version of this. It's called Colab. And if you have a Google account, it's available for free. And the links you will get for the lecture in Python, which I'll start shortly, will be open a notebook where you can actually execute code yourself. So let's see here if I just show you here if I have I open the command prompt, I do Anaconda prompt here. So you can see here it searches for Anaconda, starts here. And here I have a normal Windows command prompt, and I can then just type Python -v here, and it shows you the version I have installed here, the default version. I can also switch, I can skip that. I can also, if I just type Python here, I'm dropped into an interactive prompt. So here I can actually write Python code here and use Python as a interactive calculator. So Python is not a compiled language, it's a interpreted language that interprets line by line. And if you want to go out, exit here, I just do Control-C and I am back here again. So this is the kind of the most low-level way of running Python. You can also type Python and a file name, for example, myfile.py. So this is the default extension of Python, and you put Python code in this file, and it will execute that file for you. Then I can start Visual Studio Code. Look like this. Just gonna open a new window like this. So here is a empty window here. I can do file, new text file here, and I do like this. Save this file here as mytest.py. Now you can see here it already recognizes that this is Python, and you can see here down below here I have the Python extension installed, and it looks for the Python that is the default Python interpreter, and you can select them here. Oh, sorry, that's not what I wanted. Usually it shows me, okay, I just try to run it here. So I just run here, and you can see here it prints hello Python here. And if you want to install these packages, you go into this section here, and here you can search for Python, and it will show you all the extensions are available here. And my recommendation here is to use the Python and Python debugger from Microsoft. The other ones I can't guarantee that they work, so these ones are the most tested and available here. So this is how you run as a standalone using Visual Studio Code. Let's see here, close that one here. And you can also run a notebook, and I'll show you how you do that from the web page. So here I have my notebook here for the lecture, but you can go into Google, and if you just press your Google Drive, you press New here, and More, and you can see here there is a Google Colaboratory. So that will start up the notebook, and here you say now it's in Swedish here, but connect here, that will create a Python interpreter to run. And you can see here that now I have a Python interpreter running. I can just like before do print here. You press Shift Enter to execute, and you can see it enters code here. You can also create, for example, a text part here. So you can mix text and code in a single environment here. And then, of course, you can save it like any Google Drive document. It's also possible to start this from a let's see here if I go to my you should have a icon like this, and here you have material here, and here you have all the web-based materials available here. And the main kind of documentation and material for this course is the first link here. And if you open that, you will get into a web page here with links to the lectures here. This will be updated here when I have the lectures of 24. Here are the lecture notebooks that you can open. You also have the source code for the lecture. If there are any source code that you need to use, it's available here as well. There is the material for Python web-based material. Here's also installation and setup. So here you can go through everything here to install on your environment, installing Visual Studio Code, running Python code, everything I showed you here. And there's a spider as well. And here you have the notebooks things as well. And you can see you can get your own local notebook on your own machine as well, or your lab. So this is available here. You can see here. And here is I have a GitHub page of all the source code that you will get in this course is available here. Here is also the Fortran parts here. And in Fortran here, we will use this book here as the main documentation as well. So this is the main part. Also, the assignments will also be here. Let's see here. Exercises here. So here is a lot of exercises, and it's not, you don't have to turn in all of them. I will show you which one you should turn in. But there is plenty of exercises here if you want to try to kind of learn Python and follow along. And I will also put up information here. So if you want to follow along in my next lecture here, you can open Introduction to Python, the notebook. And that you will be able to follow along my lecture as well. And if you press the Unsalute or Connect here, you will have the ability to actually run the code as well as I go through it. So let's see. So let's start with Python. So Python is a relatively old language. It's more modern than Fortran and C, and it's created by Guido van Rossum in '91. And he wanted to create a language that supported readability directly in the code, to be able to write large applications that you can kind of follow the logic in a clear logical style. So that was one of his reasons. And there are some choices here that you perhaps, if you come from other languages like MATLAB and C, is a bit odd. For example, that source code is structured by indentation. So code blocks are defined by indentation in the code. In C++, you can indent because it looks nicer, but it's not enforced. You can put every code on a single line if you want. Not so in Python. It has some features as well that is also a bit, if you come from a typed language like C, Fortran and C++, Python is dynamically typed. And what it means is that variables can change data type during the lifetime of your code. But it's still very typed language. So every data type you assign is a distinct type. It's not like you're passing pointers around that don't have any types. We'll go through much more of that later. It also supports multiple programming paradigms. So you can program Python in in a procedure way, structured, procedural. You can also do object orientation, and you can actually also do some functional programming Python. So you can choose the style you want when you program Python. There are some language versions. So the first version was released in 91, was the 1 series. And in 2000, the 2.0 version was released. 3.0 was a major release in 2008. Problem with that was that it was not completely backwards compatible. The latest version of 2 is 2.7.18, and you shouldn't think, if you write new code, don't think about 2.7 because it's not, it's end of life, and they will not do any major updates on it. I know there are code around that relies on 2.7, but you should kind of go over to 3 at least. And currently we are at 3.12, and I think default is 3.11. It's not too important which version we use in this course. At least it should be over to 3.10. If you look at, we have a main Python page. This is the page for Python. So here you can download the reference Python interpreter. So if you want to download this, you can do that, and you can install our package yourself. However, you will not get that optimized version for numerical computing. But this there is the kind of base source for Python. The Anaconda distribution you can find here. So here you can download free download here of Anaconda and install on your computer. Language philosophy. So the idea is that you have beautiful is better than ugly, and explicit is better than implicit, simple is better than complex, and complex is better than complicated. But readabilities count. So the idea is that you should be able to read your code and understand it, which I think should be the thing for all computer languages. Yeah, there is more information here on the Python Wikipedia page. So the structure of a Python program. So as I said, Python can be text file, but you can see you can also run Python as an interactive interpreter. So it can actually, you can execute commands interactively like a computer calculator, but mostly Python programs are text file that contains rows of statements. And the text file is translated into computer instruction using a Python interpreter. So that was the Python command I typed. That is the interpreter that reads the code and translates that to low-level instructions. And it does that line by line. Empty lines are ignored. If you have an hashtag symbol before a line, it's considered a comment. And usually you have source code files of Python have the extension .py. And text file with statements are also called source code files. So this is kind of most languages have this. Typical Python program looks like this. So this first part here is just something that helps you run it in Linux and Mac environments. So this tells you here, I want a Python 3 interpreter. And it uses the command user_bin_end to figure out which one it is. It's optional, you don't have to have that. If you type Python and this source code file, it will ignore that. So it's only when you run this as a shell script in your bash environment that this will be looked at. This, however, is a bit more important. So Python is actually Unicode compliant. So you can use Unicode in your strings, so international characters. But if you want it to be interpreted correctly, you should put this in here. If you're using UTF-8 as a coding standard, then Python will know that, okay, the source code will contain Unicode international characters in print statements and so on. So if you put that there, it makes it easier for the Python interpreter. This is a comment. And here are some Python statements. So this is a typical for loop in Python. And you can see for I, this is the loop variable, and this will loop from 0 to 7. So you will also note that in Python, everything starts from 0 and goes up to zero base. So in this case, range here will generate a range from 0 to 7, which will loop over. And then you see here this colon here. This tells Python, now we have a code block. So following this statement, there will be an indented code block. So you can see here, I have a print statement here, and it's indented here by 4 characters. And that belongs to the for loop. So if I run this now, you can see it goes from 0 to 7 and prints out. If I put the print statement here, like this, and run the code again, you can see here that this statement is not part of the code block. It's outside. Indentation matters. If I do like this, it's part of the code block and it executes every time this loop executes. So that's kind of short introduction to how you structure Python code.
I have a short question.
Yeah?
You said that the hashtag is for comments.
Yes.
How does the program knows that the coding thing and also this environment is not only comments and not entirely ignored? Where do I see that?
So in this case, it's the hashtag here is also a comment in the Bash scripting language.
Yeah.
So when you execute as a script, the Bash interpreter will look at this and see what the rest should be executed in. So if you run this as a Python interpreter, Python will ignore this.
Yeah.
Only when it's executed as a standalone script that you have set the execution permission, Bash will look at the first line and see, okay, I will run this following source code with a Python 3 interpreter that is found by this command there. So it's not, if you run Python and this source code file, Python will completely ignore that. It will only look at, this is part of the Python standard. This one is something from the Bash. So you can have that the same thing with you text files that you want to interpret as a Bash script. You also put this hash pang in the beginning to indicate that it should use bin shell to execute the script. So it's a Unix thing. So this first line is interpreted as Python as a comment. It's just interpreted by this when you execute the script by the Bash script environment. But it's optional. You don't have to put them there.
And the second one is then read in the Python for text processing thing.
Yes, that will be interpreted by Python.
And that is what these minus does.
Yeah. So there is a convention. If you put that in your source code file, the Python interpreter will switch to Unicode, so you can have international characters. Otherwise, it uses normal ASCII. So it's just for information. Please, I'm using international characters.
So that's the only hashtag which is not ignored.
Yes.
Okay, good.
There could be more. I'm not sure, but it's
just for the logic.
Yeah, for that. Okay. Yeah. Perhaps we should have a short break, and then 10 minutes, and we continue. So let's see. So to continue on, so most of the functionality of Python is actually provided as functions, and Python is also a language, but it's also a set of runtime packages. Basically, a library of functions that you can use to implement your code. And a function is called by giving its name followed by parentheses. And here the most commonly used function in Python is probably the print statement here. So the function name is print, and then the parameters is given in a parenthesis like this. So this is how you call a function in Python. In Fortran, you do call of the function name. In Python, you just call the function name like this and provide parameters. Even if a function doesn't have any parameters, you still have to give the parentheses to call the function. Yeah, so you can also call a preset without any functions, so any parameters, and it just give the parentheses. So in Python, there is no distinction between a function and subroutine procedure as a return thing. So all functions within Python can return values. Here, a function here, for example, for math library here, ABS, and to value of -4, you can return on the left side just like one of the other languages. A bit different from other languages is that you can actually also return multiple variables from functions. So then you just put a list here like qcomr and define here. And of course, the function has support multiple variables as well. So then it assigns qr the result of this function call. So So in any language, one of the most important things is to be able to store a reference data number. And in Python, use variables to refer to data. And in Python, it's actually not variable itself that stores the data. It's all variables are reference to a data location in memory. So like a ticket to you try in the code at the right, you get a variable that is this ticket points to your code. Also, one thing special with variables in Python is you don't have to specify the type. So the type is determined from the assigned to the data type, to the variable. So here, a equals 1. Here, that's still integer value, it will become an integer. Then maybe 15 is also an integer. Equals special floating points, use decimal points. So this is 40.2, that's a floating point. Okay. So you don't have these as floating point, you have just 1 and 0, and it's floating point. Otherwise, it's an integer. Strings, I will come back to that later, the whole script itself, but just assign variable coded number of characters, but it's in the string. This I'm going to combine those two, so I write some list right here inside the list, and that's it, a list of index of Python. And here you also see that I can reuse a, so now I type another string, I'll change it during the code. Now a points to string in memory. Naming the rest, so there's an English alphabet, but I put it difficult to look at variables as well, so we'll try this. So it's actually works. Cross numbers in variables, no special characters except for the source. You don't start a variable number, and variables are sensitive, so uppercase is in lowercase, which is true by default, so you have this before everything is sensitive. So another variable is difficult, like first name, it doesn't start with a number, then underscore. First name, number, I2, it's not allowed is start with a number, and then there's all you here, but it's really works. So as if variables are reference item, same with variable assignments, they never take for the value, it's here, and then it declares that main variable reference, the variable, and that refers to for that value. So if you look at code here, in memory, it's going to be variable that points to memory located, right here, B here, place 4. So it's variable reference to different locations. So what if I do, it's A to B. In line, will be assigned to A will assign value B, but in this case, it's a bit different. You say that A equals to B, and the location is 4. But A, B, 4, not the value of the context location. And if you try to assign A again, you see that the assignment is A points to now, okay, but if and now it's fine. Well, if I location is not it will find B. So this is the first time, it's not that we can. Also, check out using I, you know, you have to variables. You still have to illustrate this is really so A equals to B, I and B, and then you always see the difference. So we start here, here, these are first, and A to B, I see some point relation. A to 1, and 0 relation. But you think about that, you know, size of the difference. You know that works. So it's not so it's not right. And so now equals to here, A equals B, so it's going to be the other page something, and it's A equals to that, and now you equals to if you add it, and these are for it. I love this figure, but this is the regular relation for certain and the idea for and have the other in relation as well. There are 8 sentences, okay, so that's a big question. I'm not able to consider another one. I think you see so most and cases of pain so the cycle to roll through this. That's what also this is what I want to do. And just dictionary request application use question and never. But you have to understand if the subject so you see some facts into the visual purpose. This is the very interesting with this is the sorry if I do something. You like this. You like the rules and you like the rules and the rules. And you also you saw it when you have a very interesting you have a this one is you see not like for the and not just the fact we start with these are so and print values 4 so has the ID 128. So they share the memory location now. Also, if you will empty the list, B will still point to that location. So it will not be erased. As long as there is some variable pointing to memory location, it will be preserved in memory. You can also use index notation to access parts of the list. So in this case, we have values here from starting from 1 going up, but not including 3. So I will try to explain them better here in this very weak image. Let's see if we can change. So 1, 2, 3 goes from position 1 up, but not including 3. So it's less than here. So that is kind of the intuitive would be 1, 2, 3, but it's not. It's those two only. Then we have 1 to -1. That is from position 1 to, but not including the last item. Values 3, colon starts at 3 and goes all the way to the end. -2, colon starting at 0, going to the next last item here, 3. -3, colon goes the other way direct. So it's from -3 to all the way to the right. So this is the way how you can get out values from lists using index notation. So how do you then know how long a list is? Then we come to one of the most generic functions in Python there is. It's called len. So len function can be used on any data type in Python to query at least the data types that contains multiple items. That will return the number of items there is in that container. So in this case, I have values here. If I run that, it prints out there are 7 values in the values variable, and it should be around 1, 2, 3, 4, 5, 6, 7. Okay, it should be. Okay, I have to execute that one first. And we'll see here. One, 2, 3, 4, 5, 6, 7, or 7, sorry. Just have to be sure. It was right. You can modify list using methods connected to the list object. So now we're getting into a bit of the object orientation part here. So values is an object. It has methods that you can operate on the object. So one of those methods is append. And it's just like it sounds like, it adds something to the end of the list. And then you have insert, and here you can insert things at a specific position. So one here will squeeze a value into before number 3 here. So you can see here, it position 1, insert it here, move the rest of the list to the right. You can, of course, remove things as well. Then there is a method called remove. And here you give the value that you want to remove. So in this case, remove squeeze, and we'll figure out, okay, I will remove the string squeeze. So you can see here, before remove, there was a squeeze. After remove, the string is gone. There is also a generic function called delete, which you can use to delete values in the list. So in this case, you can type del, and then the item you want to remove from the list. So now it removes the number 1 here, and afterwards the 3 is left. You can also use ranges like we had before. So you can do delete 3 : and then it will delete all items from 3 to the end of the list. So now we have a very short list. There is also a method called pop that will convert a list to a stack type data type, or you can add it and delete it from the end of the list. So if you do values.pop, it will take the last item in the list and return it, but also remove it from the list. So now V will actually contain the removed value. So now it removed number 4, and you can see the list is a bit smaller now after the pop. Clearing a list. Here are multiple ways of doing that. So one simple thing is just to assign an empty list. Then the list will be kind of don't have any owner anymore, and it will automatically delete it. But you can see here that if I do A equals to this list, B equals to A, and I do A equals to an empty list, that doesn't clear the actual data, because now B is an owner of the previous list. And if I print it out here, you can see that B still maintains the items in that list. If you really, really want to delete the items in the list, you can use the clear method. So clear will actually delete the items in the list. So if we do the same thing here, we do A equals to this list, we tell B equals to A, and then we do clear, and then we should have a different result here. So now you see B is also empty. Yeah.
Follow the example of 40. If you change one value in list A, so B will also follow the change.
Yes.
But how can I do other way? So I change the value in A, but I want the B stay.
And there's the next part here.
Okay.
There is a way you can use, there is a copy method that you can use to get a copy of the list instead of if you do A equals to B, that's not a copy. That's just an assignment that A and B points to the same thing. If you want A to B become a copy, just do B equals to A dot copy. I will come to that shortly as well. Lists can also be nested, so you can have lists of lists. So in this case here, I have A equals to a contained list here within. And if I print A2 here, so that is the 0, 1, 2, it will print me a list here as well. You can access items from a nested list by just nesting or adding more brackets to the reference here. So in this case, A2, the 0 elements of the contained list here, I do 2 here and then 0. And if I want a second element here, I can do 1. So like that. So in this way, we can very quickly create two-dimensional structures. So for example, here I will create a spreadsheet. First, I create an empty list. And then I will use a trick in Python that if you multiply a list with a multiplication operator, it will actually add items to the list. It will create a list with 10 items here. So this here is actually 10 zeros, a list with 10 zeros. So it's just a quick way of quickly creating a large list. I append them to this list here, so it will be a spreadsheet containing 4 rows. And then I can check the length of the spreadsheet here, and that will return me the length of the main list here. So here you can see here I have a print spreadsheet. You have one list here of 10. Next row here is also 10 items. And I print the length here. I get 4 because I have 4 items in the main list. And then I can access first row here with 0, and the 5th element here, that is 0, of course, because I have just zeros in this list. Also to illustrate this multiplication thing here, so 5 here multiplied by 6 will give me a list of 6 items. It's a very quick way of creating lists with many items in them. And then we also have this more things that you have to think about when you're doing lists in Python here. So B equals to 3, a list with 3 and 4. Then I do A equals to 1, 2, B, 5, 6. So I add my variable B into my A list. And if I do B0 minus 1 and A2 1 minus 2, and I print this, you can see here that modifying B will modify A as well. So there is this list here is actually the same memory location as B. So the actual structure looks like this. You have B pointing to a list of 3 and 4. A have a list of 1, 2, and then a reference to this list here, 5, 6. Modifying anything here will also modify the things that you have in this list here. And here I come to this copy method. So if I don't want this, if I actually want a copy of B in my list, then I can do b.copy here. That will return a list that is a copy of this one here. So if I do the same operations now again, you can see here I modify B, but it's still the same values in the A list. And that looks something like this here. So B is minus 4, 1. I do B copy. That is now pointing to this one here. So this is the original one, and after the modification here, B points to this one here. But you see there's a standalone copy of 3 and 4. And now we come to another data type that is very similar to a list, but it's not a list. There are some properties that kind of make it different. So tuple is ordered, and a tuple can't be changed. So these are lists that you define, but you can't change them. And also, you don't have square brackets, you use parentheses now instead. And why do we have this? That is because they are faster. So a list that you don't have to modify, you can optimize the access methods to that. So this is makes the code much faster if you use that. Also, usually when values return from a function are returned as tuples. So list of variables, that is a tuple. So if you do like this, instead of using brackets, I just do parentheses around it. I can print them just like a normal. I can access them just like a list. So you still use the brackets to access. So the brackets is on a variable is kind of a index operator to access on an element. So you don't have to use parentheses here to access a tuple. What do you think happens when I do this? We'll try. Yes, because you're not allowed to change a tuple. You can define a tuple, you're not allowed to change it or modify it. So if I do a equals 0, tuple algorithm does not support item assignment. So it's a read-only container. But on the other hand, it's very easy to create a new tuple. So I can do stuff like this, a equals a plus, and then this tuple here. And that will kind of modify the tuple. But then you do some operation, and there is a copy involved and so on. But so you can quickly create a new tuple from an existing one. And that brings us into strings, which are also immutable in Python. So when you create a string, you can't change it. The characters in the string. I don't know how two codes are the same here. Okay, we'll skip one. And you also see that there are multiple ways of creating strings in Python. And I will go through some of them. You just assign them like this with quotes. And you can also assign them with single quotes. And that can be useful if you want to use double quotes in your string. You can use single quotes on the outside of the string. Very simple. So in this case, I have single quote inside my string. I use double quotes on the outside. I can keep this single quote inside my string. I can also use the same thing here. I can use single quotes on the outside and have double quotes on the inside here. You can also, the default string in Python can also have something called control characters built into the string, or in the string here. So if you want to have a backslash character, for example, you can do backslash backslash, because all the strings or all the backslash in the string has a special meaning. And that's why if you want to backslash, you have to actually do two backslashes. You can also, if you have a single quote string and you want a single quote, you can do backslash single quote. Other way around, if you want a double quote, you can do backslash double quote. If you want a new line, you can do backslash n. If you want a tab, you can do backslash t. So in this case here, as an example, I have a string here. And you can see here I have a backslash n here. And that means a new line. So if I run this, it will actually break the line and print it over two lines. It's very similar to, if you're familiar with C, that's the same kind of character handler. And I suspect it comes from Python is implemented in C as well. So. But sometimes you don't want to use this. You want to kind of actually print out the backslash characters. And then you can do that by prefixing the string with an R. And that is equivalent to a raw string. So then Python kind of turn off all control character interpretation and just print out what is in the string. So if I run this here, you can see here that first we'll print out on a single line with the backslash n in it. And then you can do raw, the standard string here is printed with the actual new line character interpreted as a new line. There's also another string, I usually call them triple quoted strings. So they start with, you give them either 3 double quotes or 3 single quotes. And then everything that comes after this quote is interpreted like it's formatted in a text editor. So if you have a line break here, a line break will go into the string. Here we'll also go a line break, and here as well. And this is a perfect way if you want to have templates for configuration files or anything. You can put them in triple quoted strings, enter them just like they are in the text file that you want to create, and it will print it out just like you edited it here. So you can see here are 3 lines here. I have 3 lines here, and it interprets exactly like it. You can also, if you do, for example, some spaces here, that will also be reflected in the output. Just like arrays and tuples, you can use len to query the length of a string. So in this case, I just do len s1 and you get the length of the string. Same thing with s2 here. And as I said before, there's no problem that things are immutable. It's very easy to create new strings in Python. So if you have 2 strings here, it's fun with Python, and you s3, s1 plus s2, you get a new string. So it's very quickly to add things together and create new strings. You can also use, like we had in the list, you can use the multiplication operator to create strings with a certain character, for example. So, for example, I have a string here. I want to underline it in my text. So I want to create a string that is equally long as this string here. So I do s2 equals to the string dash times the length of s1. And now I get a string that contains the underlying characters with the same length as the top one here. It's quite cool. Another really good things or task that if you process text files, you usually have parameters separated by spaces, for example, or comma signs or semicolons. And one common task is to divide up them to get a list of the separated items. And a string object, an object again, has a method called split. And you can tell that if you call that on a string, it will return you a list of all the items separated in the string. So in this case, this is a sentence here with a lot of words. They're separated with spaces. So by default, it will split on space. So in this case, I will get a word list here of my sentence here as a list, like this. You can also, if you have a input file, for example, that is separated with commas or semicolons, so you want to kind of process that, you can do that as well. You can just tell Python here that I want to separate on the comma instead. And then you can see here it will separate on the commas instead. I think you could also have like this, and it will remove the spaces as well. Okay, you can see here. So you can actually see that there is a comma and a space. And I can actually have multiple characters here as well. And then you can see it splits a bit nicer without adding some extra spacement. So this can, for example, combined with a list interpreter that converts all these strings into values as well. I'll come back to that later. You can go the other way around as well. If you have a list and you want to create a string, you can use the method called join. And the syntax of this is a bit odd. So I have here a list of words, and I want to join them together with spaces. I actually have to use it on the space object here. So this is a string, empty string, dot join, and then list of strings here. This will create a string that is separated with these words, separate with spaces. Same thing with a comma here. And then if I want to create a string without any spaces, I can just do an empty string like this. So I run this. So you can see here that it will create a sentence here with spaces, a center with or a list with a string with commas in between, and then just put everything together like without spaces. So what you have to think about is if you want to use join, you have to think about what you want to join it with and then the dot. So it's a bit, you have to think in reverse. Another common operation with strings is finding things in strings. And here you have a long string here. This is also what you can do with, if you have very long string, you want to have multiple lines, you can have a backslash here on the line that will continue the line to the next line and combine all these strings together. But there is an operator in Python called in, which you can use on lists, on dictionaries, on tuples, and it returns true if the value here is in S. So it's really like, do you have a string called vocalia in string S? So let's see. Yes, so it returns true because it's here. But that already returns one instance. So it doesn't return where it is, it's just that it's in there. But I don't give you any where it is. If you want to know where it is in the string, you have to use the find method. So s.find will find the first instance of that text and return the position of it. In this case here, it will find it on 4, so this is the first one. And you can see here is the second one. And there is a second optional argument to find, and that is where it should search for the next, continue the search. So in this case, I don't want to start searching from the same position here, because then it will return 0 here, because it's the first item here, but I can just put +1. It will start from this character forward, and you find the next one here. 441. And if it doesn't find it, it will return -1. So you can see here, there is no Python in this string, so it returns -1. So you can see here, there's a lot of things that you can use when you're processing files here. So strings are very good at that. Another thing that is often done is you read a string and you want to get rid of leading spaces or trailing spaces. If you want to get rid of both leading and trailing, you can use the strip method, and that will remove the trailing space and the leading space and the trailing space. So I printed them with kind of characters to see how the string looks like, and now you can see there is no trailing and leading space in this string. There are special versions of this rstrip that will strip on the right side, and then there is one that strips on the left side. So you can see here, this is the right side, and this is the left side here. As I said before, we define the data types by assigning them, but you can actually query the type of the data as well. There is a function called type that returns you the real type ID of the variable. So you can see here that if you print type A, it says class int. So A is of the class integer, and class float is B. And also, to be really confusing, float is not the same thing as the float data type in C. So float is a double, so by default. So there is no float data type in Python. There is a float data type in NumPy, but I'll come back to that later. But the normal data type here is always double. The same precision as double in C and C++. Another really cool data type is the dictionary. And a dictionary is a special form of data structure where you store key-value pairs. So in a list, you have the key is the value inside a list, or the index of the person in the list. In a dictionary, you define your own indexes. And a dictionary is defined using curly brackets, approximately like you do with empty brackets in the list and a tuple. And then you always assign in pairs. So here you have values, Petra and a number, David and a telephone number, Ulla. So a key value with a colon in between, key value, key value. And if you print them out, you can see it looks like this. And you can also, you can access this by giving the key as the index to the dictionary. It will retrieve that from the list. And it's very quick to do that. So it's stored in a kind of a search tree. So it finds things quickly in the tree. You can create new values also by assigning, just like we do with the list here, values, bracket, key, and the value. And you assign it the value like this. And it will add a value to the list. Also to the dictionary. Finding is also very similar to what we did with in searching the strings. So here you can see, is Petra in index here? Yes, but Bosse is not in the index, and it says false. So it's a you can very quickly search a dictionary to see if there is items in the dictionary. And also the data types, you can have any data types as a key, any data type as a value. So it's a very flexible data structure. Same thing, if you want to have the number of elements, you do len. And I said before, adding is just assigning new value key pairs just like this. There is no append here, you just do square bracket, new key, value. Like this. And also if there already is a key, it's overwritten. So you can't have two keys of the same string in this. But what you can do just with the strings, you can combine multiple data types into a dictionary. So you can mix and match, making dictionaries combined with strings and variables a very flexible data structure to store things. And you will also, if you have, any of you have looked at JSON files, JSON files are almost identical to the dictionary list combination in Python. So here you have config, curly brackets, then you have a new key here, general, and that key stores another dictionary with two keys, like this. We have another key here, constant, that also stores a dictionary here with two values. You have an items here that store values, and that is a list here. So here we have dictionaries within dictionaries. We have normal variables, we have a list inside of here as well. And that gives you the ability to actually create really flexible data structure here. So I will, for example, this is a configuration file. I want to have the username in the general section. So I can do config general username. That will go into the general section, return this string. I can have the constants here, pi, then I will get this value here. Super flexible. Let's see here. I can it's slow here. Yeah. There are short assignments here. You can bring them home. You can do them yourself. And the idea is that you have code here. You can modify this one here. There is a solution here. And I see here that I already filled them out. That was not so good. I will fix it. But you can. There is a solution here. Show code here. Then you can show the solution to that. Okay. Any questions? You can continue on, and if you want to, the lecture is available, and you can browse along. I will continue on Thursday again.